Welcome learners, welcome to UGC lecture series on principles of laser or laser physics. I am Dr. Masilamani, a formerly professor in Anna University and King Saud University. Once upon a time I was a distinguished professor in laser physics. In this particular lecture series you will see the essential principles of lasers, essential features of laser, what is so special about the laser, first thing you should know, and then you will see some of the simple experiments which will show the distinct difference between laser and ordinary light, and then you will see the theories, Einstein theory behind laser action, how do we construct lasers, what are the engineering aspect and theoretical basis, at least the elementary aspect of theoretical basis for laser physics, and later you will see description about a variety of lasers. You have gas lasers, liquid laser, solid state laser, and then I will touch upon some of the most important applications of lasers, particularly in the medical field and in communication. All put together will constitute about 35 to 40 lectures, and I would try to make it as simple as possible so that every one of you understand and get the proper hang of the essential features or the essence of laser physics. Let us go. For most of the time we say laser is a light extraordinary. I hope you must have heard about Newton's experiment. When Newton showed, I think that was about 1700, he showed that white light that comes from the sunlight is a composite of so many colors, rainbow, like there are violet, blue, green, about 7 colors. Newton, he has opened up a new world, and he was an extraordinary physicist, and he has opened up a new world, that is what he said. In a similar fashion, in 1960, laser was designed by Theodor Neumann, and he has opened up a totally new device, new instrument, which had a wide range of applications, unbelievably range of application from a medical field to material processing and communication. These are 3 major applications, because this laser is a light, but is an extraordinary light. I will just show up some of these and just mention few of the examples or few of the achievements already done by lasers. A ruby laser can be sent from the earth up to the moon and get reflected, measure the distance between earth and moon with an accuracy of about 30 centimeter. Just imagine. Another laser, a ruby laser, is a solid state laser. A dye laser is a liquid laser. This laser can be fed into optical fiber, and the optical fiber can be inserted through the mouth, and it can reach stomach or any part of the internal organ and treat cancer. This also has been achieved. This is common in many of the hospitals abroad, and it is becoming common here also. Another important application which must have stunned the world is an assembly of neodymium laser can be focused to produce controlled fusion, bringing 2 atoms together, fuse them together. When there is a nuclear fusion takes place, enormous energy is released. That kind of laser is called Shiva's laser, because Shiva, according to our Hindu mythology, is a god of destruction, and this power that comes out from the laser fusion could destroy many things because of the enormous energy released. Another laser that you must have heard about is even being used is it can send a laser bullet so that it can destroy a satellite, or during the Gulf War you must have heard about Scud missile collision, and that was directed by laser. And another very common application is a helium ion laser can produce a lensless photograph which is called hologram, which will give a 3-dimensional image of an object. Another very common laser is a semiconductor laser, which can help transmit the entire content of a book before you finish reading this sentence. It is so fast. Right now India is moving from 2G communication to 3G and 4G. 5G communication is becoming popular, common in many parts of the world, including India. For this 5G communication, for 4G communication, the channel which brings this is an optical fiber. If you today go back, if you have a Wi-Fi in your house, look for a modem, ask some technician to show what it is there inside. He will show a beautiful yellow fiber, that is an optical fiber that carries enormous amount of information using laser as a modulator. That means, a laser plus optical fiber has transformed the whole domain of communication, telecommunication. These are all major achievements. Of course, you must have seen some of the common applications in a supermarket. You would see the laser scanner for getting the price, making bill for the potato or the whatever you bought. And you know the laser printers, very common, laser photocopier, all these are very common examples. Now, all these put together makes laser is a very common tool with a wide range of application in a wide range of field also. From that point of view, we say laser is really an extraordinary type of light, but still it is a light. So, it has its own constraint of being a light. An ordinary light, not a laser, a light like this, like the tube light or the light from the sun, all of them have certain properties. All these properties, all these constraints that the light has is there for laser also. Let us sum up the properties of ordinary light, so that later, the later part of this lecture, you will understand what is so extraordinary about laser. Now, coming back, like any other light, laser also is an electromagnetic wave. First thing, it travels with a velocity of 3 into 10 power 8 meter per second in vacuum. It is a transverse wave. It exhibits all the properties of reflection, refraction, interference, diffraction, polarization. All these properties you must have heard about in your undergrad. Now, let us sum up all these for a quick understanding of feature. Reflection of a light is a phenomena of light bouncing back in the same medium. When it bounces back, the angle of incidence is equal to angle of reflection. This is what you must have studied even in your 8th standard. This is the property of reflection. Next one, refraction is a phenomenon where light passes from one medium to another medium, say from air to water or from air to glass. When light travels from air to glass, it will not go in a straight line. It will go and bend towards the normal when the medium is a heavier medium or it is a denser medium. For example, you can see from the figure, when light goes from air to glass, it bends towards the normal since glass is a denser medium, the refractive index is greater than 1. In fact, for glass it is about 1.5. Okay. All these are high school material with which you are already familiar. Another property which is which made Newton very famous is this: when you send a white light through a prism, a glass prism, it splits up into the composite, the components of the white light. This is called dispersion, which means spreading out. It spreads out into different components because white light is a mixture of all these blue, green, red light. This particular property is called dispersion. Next one is something which you are all familiar every day. When light falls, say for example from the sunlight, it enters into the sun's atmosphere, it gets scattered. Light gets scattered from the dust, from the water particle, from so many things. When this happens, the scattering is called a random reflection. Randomized reflection is called scattering. That is the simplest way of explaining. This scattering sometimes produces certain type of changes in the frequency also. One such scattering which produces changes in the frequency is called Raman effect, with which you must have heard about so many times. That is why he got Nobel Prize. Let us not go into those details. Right now what is important is a light from sunlight comes to the Earth's atmosphere, then from the scattering you can immediately explain why sun looks reddish and straight up the sky looks blue. I can explain in 1 minute. When light enters into the atmosphere, Earth's atmosphere, it undergoes random scattering. When there is a particle, the scattering is more for blue, much less for red. That means most of the white light that comes from the sunlight gets scattered. When it scatters the blue light straight up, and red is not so much scattered. So, what that reaches is a red light, or the sun looks reddish or orange or yellow because of scattering of white light on water particle or some small quantity of dust also. For the same reason, sky looks blue. You will study, or you must have studied this one more later. The diffraction is the behavior of the light which bends around a corner, provided the corner is sharp edge, or if you can look at this one, when it passes through a small hole, a small aperture of the size of 1 millimeter or even less, then since it passes through a small aperture, it will bend and undergo diffraction. It will bend around the corner, that is called diffraction. Interference, again you must have studied in the school, is a phenomenon where the amplitude of the wave, I hope you remember, you must have studied, a wave has certain amplitude, certain phase, certain wavelength, because of the, and also it has speed. The frequency of the wave anyway is always speed over wavelength. Now, in this case, in the interference, what happens is, when a light passes through two small holes, it bends around the corner in the two holes, and then at some point the amplitude of light add up. At some other point, amplitude of light gets subtracted. So, you will have maxima and minima. You will have straight lines with this no light, yes light, no light, yes light. This is the property of interference. Laser also undergoes this kind of property, and that has a lot of applications. Later you will see. Polarization is an exclusive property of electromagnetic wave, which is a transverse wave. Polarization means you confine the vibration of light in a particular y direction or x direction. That is what you do. Imagine that light is traveling in z direction. It can vibrate in x plus x minus x or plus y minus y or anywhere in between. When this happens, we say it is an unpolarized light. Then you put a polarizer. What comes out in this example is light is going in plus y axis and minus y axis. What comes out is a light vibration in electromagnetic wave, but the E vector is going up and down, plus y and minus y in this particular picture. That means what comes out is a polarized light, what falls is an unpolarized light. Again, these are all simplifications. Next important property, light is an electromagnetic wave, and an electromagnetic wave by definition has electric field and also the magnetic field. Electric field is changing, correspondingly magnetic field also changing. For example, in this case, if the light is traveling in z direction, if this is y direction, if this is x direction, electric vector will vibrate in plus y and minus y. The magnetic vector will move in x direction, while the light is moving in z direction. This is a property of any transverse wave. This is true for light, for laser, and also is true for microwave or infrared wave or X-ray or a gamma ray. All these put together, big band put together, is called electromagnetic spectrum. Now, when I have said all these are common for ordinary light and laser light, you will ask one question: in what way light is different from laser, or why you call laser a light extraordinary? There is only one difference. I repeat, there is only one difference. In ordinary light, the light comes out like a collection of wavelets from various points, totally random in direction, totally random in frequency, totally random in phase. They are totally disorderly, incoherent wavelets. That is a property of ordinary light, sunlight or your lamp or your torchlight or all the light except laser. Put them together as a thermal light. All of them are random in frequency, in phase, everything. I can give an example later, you will see what does it mean by frequency, phase, everything. Okay. On the other hand, in laser, which is a specially designed device, all the lights are coming in one direction, in one frequency and in one phase. You see the picture there, a very beautiful picture is given. You see a light coming from the ordinary lamp, the old yellow lamp, where you just send a electric current, the current goes through a tungsten wire gets heated up. Since it gets heated up, it produces light at certain wavelength, usually yellow orange. What is important is all the photons that come out from Thomas Alva Edison's tungsten lamp, tungsten wire based lamp, is all the photons are coming out at random in frequency. You can see the next part of the picture. They have different wavelength, so different frequency. Not only that, they have different directions. Some of them go like this, some of them will go like this, some of them will go like this. There is no control. Not only that, some wave will start at this point and go up like this. Another light will come slowly, come later and go very fast. All these put together, we say there is random in direction, random in frequency, random in phase, or one word, ordinary light are incoherent. In contrast, in the laser which you have shown at the bottom, you have a rectangular chamber from which laser light is coming. Now, look at this one, all the light come in a straight line in one direction, all the three are coming in the same direction. If you look at the wave property, all of them are coming up in the same direction, same frequency and same phase. That means, all of them go up, all the three waves go up and go down, go up, go down, all together simultaneously. This is what you mean by coherent orderly behavior in phase. The best example I can give, if you look at this picture, you will understand the essential property of any laser. Look at the picture in the right side first thing. In the right side, you will what has happened is, somebody has taken a snap of soldiers march past in a Republic Day parade. They have taken the picture at certain angle. You can see all the soldiers put their hand and leg simultaneously. You see there is a gap, same gap throughout in the first file, second file, third file. All of them raise their hand at a point, lower hand at some other point in time. Again, all of them raise their hand, lower their hand at different space point. Not only that, suppose I take the picture of the first row of the people, at certain time I know what it is. Then I can very well predict at what time the 100th file will come. I mean the people march coming after 100th file will come at certain time, because I know precisely what's the time difference between the first row and the second row. Not only that, listen carefully, not only that, if I know at what time the first man raises his hand, I know what time the last man at the another farther end will raise a hand, because they are correlated in space and also in time. This is what you call coherent march past. Only trained army people will behave like this. Ordinary people like us, we are not trained to move so carefully, we are not trained to move in proper sequence in time or in space. The best example what I have shown is on the left side. This is the example for a shopping crowd in USA or someplace. If you have not seen this one, do not worry, go to Ranganavan Street or any other busy street during Deepavali or Pongal or any other time, you will see the crowd moving. Suppose I go with my son, and if I lost him, my son will start crying, because he does not know where I am, at what time I will come out. There will be complete chaos, because there is no understanding between one person and another person. So, the left side is a random, is an example, classic example of light photons that come out from ordinary light like this. I told you that laser is a very coherent light, like the soldiers moving in a regular Republic Day parade. Now, watch out, the soldiers are extraordinarily organized. Because of this one, they could go up to the Himalayan mountains, they go into the sea, and they can face a big enemy, because they are trained to work together, go with certain aim, go with a certain direction, go with a certain time, go with a certain speed, go with a certain direction. In the same way, laser light is trained to come out with a certain phase, certain frequency, both I have explained. Now, the question comes, what color is the laser? You can get laser practically almost in the whole range. For example, the first laser was done using a ruby solid. You know, ruby is a very precious jewel. Mayman obtained the first laser action from that solid state laser, and that solid state laser produces a pulsed light like a bullet. It will come one shot, nothing, one shot, nothing. This is the typical example of pulsed laser, and that occurred in a wavelength of very pink red color, 694.3 nanometer. That will be a reddish light, like a more like a blood, or even a reddish than blood. That is a typical example, and that was obtained from a solid laser. You can get a laser from liquid also. The liquid, the most common liquid that you can easily get is, you must have seen fluorescein or rhodamine. These are all beautiful fluorescent dyes, which those people who work in the night, they put on the shirt, so that when a car light falls on it, it will show very brilliantly that there is a person wearing a blue or a green or a red shirt. So, immediately they will catch up and keep the driving at a safer point. This is the fluorescent material which can be converted, which should be dissolved in suitable liquid, and then it can be made into a laser. Another type of laser is a gas laser. Typical example is a helium neon laser. This particular laser produces light in the red at 632.8 nanometer. It is red. This is the most common laser which you can find in many of these laboratories at postgraduate, at MSc or even PhD level, in many of the colleges and universities in India. This is a gas laser. Now, another very common laser is a semiconductor laser. Remember, ruby is not a, ruby is a insulator solid. You cannot send current through ruby. On the other hand, in a semiconductor, which is part conducting, part non conducting, that is why we call semiconductor. When you send current through this one, you can bring the electron, one side which is rich in electron, jump into the holes in the another side, that is called NP junction diode. If you push electron from one side, it will go and fall into the hole in the right side. It produces light. This is called luminescent light. Then, if you can put this material in a proper resonator, which you will see later what do you mean by resonator, then you can get a laser from the semiconducting material. Remember, most of the time from semiconductor you will get LED, that is a light emitting diode, which is common in your TV. If you look at the TV at the bottom, you will see a red light or a blue light. That is not a laser, that is a light emitting diode. The same diode, if you specially prepare it, you will get a laser out of this one, which also is very common, very cheap. You can buy a semiconductor laser for 100 rupees. It is so cheap these days. It has become a common tool in the toy shops. Now, I have touched upon different variety of lasers, and later we will see a variety of applications also, one after another. You will go more in detail, rather deep into laser physics. Thank you.